In this video I want to show how you can make a decision about a choke coil in the power supply. And then I mean especially power supplies working on 50 Hz or 60 Hz. In tube amplifiers you will often see that this is the circuit that's used, 50 microfarad as a first capacitor, also 50 microfarad as a second capacitor, and here the choke coil. And the choke coil has specific properties. It has to damp out all the oscillations here that come from the main supply, and it can be 50 Hz in Europe and the Netherlands or 60 Hz, and often the current that is used for tube circuits is between 3 milliampere and 50 milliampere or even more. This is the classical P filter, and in this video I want to show a little bit how you can choose such a choke coil. Of course there are choke coils on the internet and made by manufacturers, but often you can also use for such a choke a standard mains transformer that was made for 110 volts or 230 volts, and when you measure the frequency on which the transformer generates, that's in my earlier video, it's the same day, 10 October 2014, so watch out for that video. When you see the frequency where this coil oscillates, it can help you to find out a good choke coil. This is, for instance, a coil that I found in a computer power supply, and I'm almost sure it's usable in another power supply, for instance for a tube amplifier. So a high voltage power supply operating on, let's say, 100 volts or 300 volts. I think it's a good choke coil here in this application here. So to test that, put down the camera, I connect that coil into the oscillator circuit that I've published today on my YouTube channel, and we're going to see now where that coil oscillates. Here is the oscillator, 143 kilohertz. This is the waveform. Set it to pure waveform. In that case I found 198 kilohertz. And that means that this coil is usable, for instance, as a choke coil. But in fact you always have to test that, whether it's usable and how good it works. So connect such an experimental choke coil here between the two caps and find out with your oscilloscope here connected to the positive via a 1 mega ohms resistor to your scope, and then study the waveform and study how good this choke will damp out all the AC frequency, so 50 Hz or 60 Hz. 60 Hz. And whether you see here on the oscilloscope a perfectly clean broad line on 100 or 300 volts. So it all depends on how you make it. And of course you can take the schematic and buy all the components perfectly, but it's a very good idea to do some experiments and test how you can make a good DC power supply with no ripple here. And the ripple here is damped out completely by the value from this choke and the value from these two capacitors. Often these two capacitors can be in the 50 micro range up to 100 micro range, but the choke here is decisive for how good you can filter out all the AC. So this was microfarad, for instance, microfarad. The choke is decisive for how good you can filter out all that ripple, all that hum that comes out of the main supply via the bridge rectifier. So in this video I only want to show how you can find out such a coil, and that you don't have to buy expensive coils, for instance here, to get good results. With your scope connected to this location via the 1 mega ohm resistor, you can find out perfectly how good this filter damps out all the nasty 50 Hz or 60 Hz frequencies. And the oscillator here can be from a good help by searching the value from the choke. And you can also wind such a choke very easily by yourself. For instance, when you take a ferrite core, so this is a toroidal core, and wind here your windings, so say 50 windings or 100 windings or 200, test it again with the oscillator, check the frequency and check how good your choke coil will damp out the 50 Hz or the 60 Hz, and that's often an experimental process. And it's very interesting to do.